slope-intercept form. You'll have some systems that are in slope-intercept form, and then I threw a couple in where they're both in standard form, so you have to solve to get them into slope-intercept form, just like on Monday's assignment. So it's a little bit tricky, but it's not too bad. Nothing that I don't think you guys can do. Totally believe in you guys. So I'll show you guys what this will look like. Let's say that we have a problem that looks like y is greater than or equal to 1/2 x minus 3. And then another linear inequality would be, let's say y is less than, let's say, 3x plus 1. So we have two linear inequalities here. Now I'm just going to approach these one at a time, and I'm going to graph them both. Now the one thing that I'm going to caution you about is when we're shading these, at first I'm going to shade very, very lightly. I'm going to look for where the two overlap, if they overlap at all. And then when I find the place where they overlap, I'm going to shade the overlap darker. Because I'm looking for not just where the shading is happening, but I'm looking for where the overlap is happening in between these two. And I'll show you what that means right now. That might sound a little confusing, but just bear with me here for a second. So I'm going to draw on my really, really rough XY axis here. Forgive me, it's notes, so it's not perfect. So here I've got my x-axis down here, and I got my y-axis going up and down here. And I'm going to go, let's go up 1, 2, 3, 4, 5, 6. Let's go down 1, 2, 3, 4, 5, 6. And I'm going to go to the right 1, 2, 3, 4, 5, 6. I'm going to go to the left 1, 2, 3, 4, 5, 6. Pretty rough, not too great. Alright, I'm going to focus in on my first linear inequality, which is this one right here. Y is greater than or equal to 1/2 x minus 3. Now first, before I even graph it, should I make this line solid or should I make this line dashed?
Solid.
Very good, Zach. How do you know that?
Because it's greater than equal to.
Mm-hmm.
Just greater than.
Awesome. It's got the line underneath it, which means it's going to be a solid line. The equal to means it's going to be a solid line. So I'm going to start by going down 3 spaces. 1, 2, 3. That's where I make my first dot. And then the 1/2 is my slope, my rise over run. I'm going to rise 1, run 2. And I could do the opposite of that as well. Drop 1, go left 2. When I connect these points, I'm going to use a solid line. If I put 0, 0 in there, I'm going to check to see if that would give me a solution. So I'm going to go 0 greater than or equal to 1/2 times 0 minus 3. So what's half of nothing? Nothing. Okay, so 0 greater than or equal to 0 minus 3. And what's 0 minus 3? Negative 3. Is 0 greater than or equal to negative 3? Okay, that's true. So I'm going to just kind of like make this idea that I should shade up here where 0, 0 is. I'm going to shade it really, really lightly. And so because I'm using a pen so it shows up on the camera, I'm just making these one directional marks just to show. If I were using a pencil, I would shade really lightly so I'm not covering everything in. So I wouldn't go like, you know, like super shady right now. I just shade really lightly at first. Okay? Now I'm going to go to the other line now. Y is less than 3x plus 1. So I'm going to go up 1 to make a dot. And then from here my slope is 3. So I'm going to rise 3, 1, 2, 3, and I'm going to run 1. Or I could do the opposite, which is down 3 and left 1. Now, when I connect this, should it be a solid line or a dashed line? Dashed. Now, I'm not interested in where these two lines connect. So I'm not looking for an intersection point here, unlike when we were graphing the solid lines. Instead, I'm interested in where the shading overlaps. I'm not interested in where the two lines connect. I'm interested in where the shading overlaps. So I'm focused here. Does this line go through 0, 0? No. So I can use 0, 0 as a check. So I'm going to put 0, 0 in here for x and for y. So I'm going to do 0 is less than 3 times 0 plus 1. 3 times 0 is how much?
0.
Okay. So 0 is less than 0 plus 1. And then 0 plus 1 is, okay, and is 0 less than 1? So that means on this line, it's a little shaky there. So that means on this line here, move this so you guys can all see everything.
This here line.
Yes, on this here line. This one here, I'm going to shade where 0, 0 is, and 0, 0 is right there. So I'm going to make these shading ones kind of this way. Again, I'm just going to kind of go lightly, and I'm going to stop, and I'm going to look for where the two shadings overlap. Okay? So I've got the shading from this line goes up here, the shading from this line goes that way, shading from this line goes this way. Where do the two of them overlap? In this kind of pie slice area right here. Do you guys see that?
Yeah.
So the two shadings overlap in this kind of pie slice area right here. So this line shades up here. Remember? This line shades over here. So they're both shaded, in this pie slicey part right there. So the part that I'm going to shade darker is the part where they're both shaded in, which is right in here. So the solution to this system of inequalities is the place where they're both shaded. Does that make any sense? Maybe, kind of, sort of. All right, let's look at this together. See if maybe it makes any more sense if you actually see the assignment. You're going to need another piece of graph paper, so go ahead and grab one. Let's look at the first 4 problems together. So you're not in your plans yet. You're still focusing on this. This is an extension of your notes.
Do you have cards for a dress code?
I do. I haven't had to use any yet this year. Does every teacher? We were all given some a few years ago.
Wait, have you had to use one before?
Yeah.
What?
For I've used cards for dress code for inappropriate T-shirt slogans, and I've used cards for dress codes for spaghetti straps, and I've used cards for dress codes for skirts that were too short.
Wait, so I can't come to school with a spaghetti strap?
You cannot know.
Or a mini.
Not even a guy?
Not even a guy can come to school with a spaghetti strap. With guys, however,
So what? Your shoulders can be strapped in my
however,
strapped in shoulders.
there was one student one male student who has come to school with spaghetti straps before.
Oh.
So don't worry about that. That has happened. It wasn't a student of mine. Don't worry. All right. So let's look at this one here. Y is greater than negative x minus 2. It's 2017, guys. Open your minds.
My mind is somewhat open.
So,
My mind is tired.
just because we're in Roundup, Montana, it's 2017. Y is greater than negative x minus 2. So we'll focus on this line first. Y is greater than negative x minus 2. And I'm going to use my pencil just so I can show you what I mean by shading in lightly. So you don't have to worry through my, my ink. So where do I start with my first dot? Anybody? Go down 2. Thank you, Zach. So I'm going to go down 2. I'm going to make a dot. And now with that negative x, what's my slope?
Negative 1.
-1. So I'm going to go down 1 and then right 1 or left 1?
Right one.
Down 1, right 1. Or I could go up 1 and left 1. So I'm just going to, just for funsies, I'm just going to follow this pattern for a little bit, just because it's kind of, I think it's kind of calming. You don't have to. At this point, you could go grab a ruler out of the drawer marked rulers, or you could use the ruler that comes with your planner that we given you. All right. So now, should I connect this line with a solid or a dashed line?
Yeah.
Great. So dashed line, gonna dash it up. Okay. And then, can I use 0, 0 as my checkpoint for this one?
Yes.
Okay. So if I put 0, 0 in, I'm going to do 0 is greater than -0 minus 2. So -0 is still just 0. And what's 0 minus 2? -2. So is 0 greater than -2? Is that true or is that false? True. So that means I'm going to shade where 0 is. And I'm going to do this just really lightly. And I'm going to do it so lightly it might not even show up on the camera. Okay, you guys see that?
Yeah.
All right. Now I'm going to go back to do the other line. So the other line is y is greater than or equal to 2x plus 1. So I'm going to go up 1, put a dot.
Go up 2,
Up 2, right 1. Awesome. Or I could do
down 2.
down 2, left 1. And again, these two lines intersect nicely, but I don't really care about the point where they intersect in this case. Instead, I'm going to care about where the shading overlaps. So when I connect these, solid or dashed, anybody?
Solid.
Great. Alright, so when I'm connecting these, Julia, can I use 0, 0 as my checkpoint? How do you know? You're right. Because the line doesn't go through 0, 0. Perfect. If it did go through 0, 0, you'd have to use something else like 1, 0, 0, 1, a billion, comma 37, whatever numbers you want to use. Okay? Yeah, that's fine. So if I use this line, so I'm going to do 0 greater than or equal to 2 times 0 plus 1. The only reason we use 0, 0 is because it's easy to use in equations. So this is 0 greater than or equal to 1. Is that true or is that false?
False.
So I'm not going to shade where 0, 0 is. I'm going to shade on the other side for this one, which means shading up here. And again, very lightly. Now for this line, I'm shading in this direction. And for this line, I'm shading in this direction. And the two lines overlap, or the two shadings. So like I've got this shading and this shading. So where do the two shadings overlap?
The top side.
Right, this kind of, do you guys see that? I know Zach sees it, but does everybody else kind of see that?
Yeah.
This triangle is where the two shadings overlap. So I'm going to go back through and I'm going to shade in this triangle here. I'm going to shade this in darker to show that I know that this is the shading that should be darker. Because this shading, every point that is inside this area is the solution to both of those inequalities. So if I picked any point from inside this area, every single point inside this area would be a solution to both of the inequalities at the same time. So it would solve the top inequality and at the same time it would solve the bottom inequality. So it's the solution to the system of inequalities. Okay? Kind of, sort of? Let's take a look at the next one here. So the next one is also in slope-intercept form, so it's hopefully not too bad. So we've got y is less than negative 1/3 x minus 1. So Nathan.
Go down 1.
Down 1. So hold on, let me mark my origin just so I can see it. So down 1, make a dot, and then what?
Go up 1, and then left 3.
Up 1, left 3. A bold choice to start us out, but I endorse it, sure. And then what else could I have done instead of going up 1 and left 3?
Down 1, right 3.
Down 1 and right 3. All right. You're off to a good start so far, Mr. Johnson. Now, when I connect these 3 points, should I connect them with a solid line or with a dashed line? You've got 2 choices here. 50-50 shot. Pretty good odds. Look at the symbol that links y and the right hand side. That's going to tell you if the line should be solid or dashed. I'm asking Mr. Johnson.
What are you asking?
I'm asking you if the line should be solid or dashed, Mr. Johnson.
Oh, dash.
Great. Awesome. So here we go. Cool. Now, let's jump over to Annabelle. Does the line go through 0, 0? Okay, can I use 0, 0 as a checkpoint then? Cool. So I'm going to put 0, 0 in for y and in for x. So I'm going to do 0 less than negative 1/3 times 0 minus 1. What's negative 1/3 of 0, Annabelle? And what's 0 minus 1? So I've got 0 less than negative 1. Is that true or is that false? Okay. So am I going to shade where 0, 0 is then? Okay. So I'm going to shade on the other side. I'm going to do it lightly. So just kind of lightly shade just to get the idea of where I should shade for that one. Nice. Megan, how do I graph this other one here? Yep. Down 3. 1, 2, 3. And then do what? Up 1, right 3. And then what else could I do? Cool. 1, 2, 3. If I could count, that would be helpful. And then, Megan, should the line be solid or dashed? Awesome. All right, and Michaela, does this second line go through 0, 0, yes or no? Okay, can I use 0, 0 as a checkpoint then? All right, so if I do that, I'm going to have 0 greater than or equal to 1/3 of 0 minus 3. What's 1/3 of 0, Megan? What's 1/3 of, or sorry, not Megan, Michaela. What's 1/3 of 0, Michaela? And what's 0 minus 3? Great. Is 0, Michaela, greater than or equal to negative 3? So should I shade 0? Okay. So I'm going to shade where 0 is on this one. I'm going to do it lightly. I'm going to look to see where the 2 shadings overlap. So Riley, where do the 2 shadings overlap? That little thing to the left. So this area right here, right? So I'm going to go back and I'm going to reshade this in darker than all the rest. Believe it or not, making little noises helps. Okay. Kind of, sort of? Does this make any sense at all to you guys?
Maybe, not a little bit.
Okay, so let's look at the hard ones now. Let's look at questions 3 and 4, where instead of being in slope-intercept, they're in standard form to start out. Question number 1, question number 2. I know. I'm excited too. I like challenges. Challenges are good. A fun game is one that gets harder as you go. Imagine if Super Mario Brothers was just level 1-1 all the way through. Okay. Well, okay.
If it was the same movie.
Just again and again and again.
Well, then,
Just the same episode of at like Every episode was the same episode again and again. Yeah. All right, so let's go through question number 3 here. I left off with Riley, so Kate, you're up. So, looking here, I've got 5x minus 3y is greater than or equal to negative 9. So I need to solve this for y first. 5x minus 3y is equal to negative 9. So I get everything that isn't y on the other side. How do I move 5x? I'm going to minus 5x from both sides. So how would I rewrite that? Great so far. I'm with you. So divide by negative 3, divide by negative 3. Oh, nice job. And then this is going to be plain y. Now, negative 5 divided by negative 3, remember, go say. And since it's a slope, leave it as a fraction. So what would the fraction be? Awesome. Drop down the x. And then what does it turn into? Good job. Nice job. So here's this line. Oh yeah, thank you. Nice catch. So there's one line that you have to graph. Y is less than or equal to 5 over 3x plus 3. Okay? So when you graph that, would it need to be a solid or a dashed line? And you're going all out of shape. It's dark. So it'd be a solid line, right? So you go up 3, and then you go up 5, right 3, or go back to where you started, and go down 5, left 3. Next, with a solid line, could you use 0, 0 to check? You absolutely could. You get 0 is less than or equal to 3, which is true. So you're going to shade where 0, 0 is, which is in the downish direction. Downish backwards. Downish backwards direction. Okay. Kind of sort of. Great. Now, to do the next one here, you're going to help me out with that one. So we've got x plus 3y is less than or equal to 9, or negative 9. X plus 3y is less than or equal to negative 9. So, what do we have to do first?
X.
Great, so we're in minus x, minus x. So what do I write for my next line?
3y greater than or equal.
I'm with you, but that's a less than or equal to.
Okay.
It's fine. It's okay. And then what do I write now?
Negative x minus 9.
Perfect. What next?
5.
Okay, divide by 3, divide by 3, divide by 3. Okay, this cancels. And then what does that turn into?
Y.
Perfect.
What?
Less than or equal to? You got it. And then, since this is negative x, when you divide it by 3, what does it turn into?
Negative 1.
Perfect. Drop down the x, and then what is negative 9 divided by 3 turn into? Nice. Perfect. So for that one, you're going to go down 3, and then down 1, right 3, or up 1, left 3, and then 3. So that one, can you use 0, 0 as a check one? You super can. You get 0 is less than or equal to negative 3, which is not true, so you're not going to shade 0, you're going to shade in the downish direction again. You had this one that shaded in the downish direction, and this one that shaded in the downish direction. Both shading downish. So like your super shaded area is this kind of like down triangle down there. Right, downish shadow top. Does that make any sense? Is that helpful? Or should I just do it on it? Nah. Y'all need to do stuff for yourselves. Y'all need to learn some self-sufficiency.
Why do you say?
No, I didn't say no. Alright. Let you guys finish that up and then we'll look at the report. No, 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 no. No! Nine. Time and nap time.
Yes, nap time.
Yes.
over here. Okay, we're going to minus 5x, minus 5x. So what do we write now? Perfect. And we're done. So go down 3, and then down 5, right 1. If you have room to. I don't know if you have room to. If you don't, then you would go up 5, left 1. You connect it with the solid line. And then you can use 0, 0 as a check. Use 0, 0 as a check. 0 is greater than negative 3. You would shade in rightish, kind of upish, kind of rightish. We're there. Direction. Yep. That. Those are ways. Okay, shade like that. Okay. Sorry, I'll let you finish. Let me finish. You were drafting. Oh, you're right. Okay. So x minus y less than negative. So what do we need to do to get that into slope intercept form? So minus x minus x, and then what do we have after that? Perfect. What now? Okay. Now one thing you have to watch out when you divide by a negative number. It does that. One other thing it especially does, which, yeah, it switches inequality. So this turns into what? Mm-hmm. Mm-hmm. Great. So up 3, 1 right 1, down 1 left 1. Like that. And then upish. So this one was shaded upish, or rightish upish. This one is shaded upish leftish. You get kind of this center upish thing that's shaded. That makes any sense? No, it doesn't make sense? I'll stop now. Okay. So, yeah.
So I have a question. Okay, so
Just.
like if the world did end
Oh.
today,
Oh.
we would see it in January 25th, and we would be like, oh, well, the world ended on January 25th.
No, we
But
wouldn't.
it not do anything.
Hey, let me finish.
Okay. But then, the other people who are not in today, how would like we settle that dispute?
Let the war.
Okay,
Let the war.
What time is it right now?
We would be dead.
The
Done.
8:55.
What time is it in New York?
It'd be 10:55.
But it's 8:55.
Yeah, well, okay, say it was like,
Oh my God.
say we were, okay,
No. Okay, Tyler. What time is it right now?
8:55.
What time is it in New York? But you just said it was 8.
But in New York, there's a time zone.
Yeah, but you just said it was 8:55. How can it be 10:55? It's 8:55.
Because we're separate
in
time
Montana,
zones.
Yeah,
Yeah.
that's the answer to the question.
That's logic.
How, Kate? Tyler, guess how many time zones there are on the planet? Just take a guess. Yeah. Why do you think there are 24
Oh my
time
God,
zones?
you read this more geography than you said seriously? Because it's like 24 hours a day.
It's exactly what.
Y'all are crazy.
But people are different time zones. They die.
Okay.
I'm confused.
I
I'm
think
confused.
you just confused yourself. No, it's not that they would die first. If the world ended at like the exact same moment, it's just that it would end at the same moment, but we would disagree about what that moment, like we would disagree about what to call the moment, but the moment would be the same.
Yeah, because in like New York it'd be 2 hours later than here.
Right, but it would be the same time. It's just we would disagree about what to
Aliens
call it.
came and inhabited.
Okay, okay, quiet. Okay, it would be the same time. It would be like the exact same moment. It's just we would disagree about what to call the moment. And that's okay.
Is this guy?
Yes, you can work with your groups if you want to.
You're cutting this out, right?
What? Why would we have a dispute over the world ending when we're all dead?
Exactly.
This is gonna be on YouTube now.
Oh my god.
Good lord.